Hey, this is Don from Padlock Technologies again with another video. This video is going to be a lab video on GetVPN. Now, remember, in a couple videos I've made before, I'll put one in the card somewhere up here somewhere. Um, I talked about how MPLS is not secure per se. It's traffic separation, it's not encryption. So the MPLS traffic is still clear text. So if someone wanted to do a Wireshark, they can kind of see the data that's going through, right? Now with GetVPN, that kind of mitigates that issue because it allows you to encrypt traffic in your MPLS environment. And there are some components there. One is a key server. In the lab, I'm going to show you redundancy because I have two key servers. I'll show you the redundant setup, but it's going to be a simple MPLS configuration. I'll show you the clear text first through Wireshark, and then I will apply GetVPN, and then you'll see that traffic will be encrypted going from site A to site B. Let's go ahead and get in the lab and show you what that looks like. So here we go. We are in the lab here. Simple MPLS setup. This is MPLS using LDP. I'm not doing subnet routing or MPLS TE, which is RSVP. I got videos on that as well if you want to see that. There's two PEs. Everything else is a P in the middle. And then we have two CEs here. Now, what I want to draw your attention to is down here, the key servers. I have one key server and another key server here. So if we click on key server 1 and key server 2. Now the significance of this is single point of failure and the attack point, right? So single point of failure, because I have two, is redundant. So the single point of failure is gone, but these key servers are now an attack point, right? If an attacker compromises the key servers, you're in trouble because it pretty much blows up the entire GetVPN setup, right? So you really have to secure these key servers to make sure somebody cannot attack these key servers. Meaning, disabling unused services, not allowing people to log directly in, having some type of monitoring software, syslog software that will get syslog from the key server to tell you if somebody's trying to, brute force and stuff like that. So what I want to actually show you is from the key server setup is this is going to be ICAV2. ICAV1. This is not going to be an ICAV2 setup. So you're going to see the ISACEM policy, the ISACEM keys. You're going to see an IPsec transform set, and then you're going to see an IPsec profile. And I'm going to explain everything in the GDOI configurations and show you how those pieces map together. So if we do show run crypto, just so you can see the crypto stuff, I'm not using GCM ciphers as well. So GCM is your elliptical curve and all that other stuff, but I would really do that in a ICAF2s if I wanted to. Now, let's go down to your ISACEM policy, simple AES 256, SHA-256 for integrity. It's going to be authenticating with the pre-shared key. Diffie-Hellman group is 14. Best Diffie-Hellman groups of 14, 19, and 21, even though 21, I believe, is going to get deprecated. For the lab only, we have a simple key for everyone. Now, if you want to be more secure, you would actually use the crypto ISACEM key for specific neighbors. You wouldn't just do a blanket everyone statement, right? Then your transform set, AES 256, SHA 256 mode transport. We want to do transport mode because we do not want to duplicate the IP addresses. All right. The difference between tunnel mode and transport mode, tunnel mode is going to put a whole new IP header on it. Transform mode is not going to duplicate the IP header. So it will use the same IP header that it was using before and not create a brand new one with a duplicate IP addresses. You don't want to do that. That's why you would use transport mode. That's why on normal VTIs or GRE tunnels, you use transport mode and you don't use tunnel mode because you don't want to repeat the same source and destination address. Then we have our IPsec profile here. I don't know why that just popped up, but we have our IPsec profile here that just matches the transform set. And then I'm doing perfect forward perfect forward secrecy, which is basically running Diffie-Hellman again. So PFS is just running Diffie-Hellman again to it's going to avoid someone getting the keying material, and the likelihood of someone getting your keying material is pretty low. But this is an extra precaution to run Diffie-Hellman again, so that you get new keying material to do the second tunnel, so phase 2 tunnel encryption. Technically, you don't have to do that. And now we're going to get to the GDOI configurations or the Get VPN configuration. So all this here is the Get VPN configuration. So minimum minimum stuff you need the identity number. That's going to identify the group that you're going to be in. So group encryption domain, group encryption transport VPN. So you need to understand the identity number there identifies the group that you're in. For the key server, the server is going to be local. The rekey lifetime is 5 minutes. So I'm going to send a rekey message every 5 minutes. The authentication is going to be another key. Remember I said in Get VPN, you get the tech, the KEK, the interesting traffic, and the public key. Well, this is going to be the public key that's going to be sent to each of my members in my Get VPN. So when I send the rekey messages with that I sign with the KEK, then I'm going to verify that, hey, this is the right key server by using the public key to decrypt that. Now, in normal Get VPN, they use multicast to send the rekey messages. In this example, we're going to use unicast because it's a small example. So we're going to send those rekeys using unicast. The SA IPsec, we're going to match that IPsec profile that we have, and we're going to match a access list of 100. Then we have our address to say, hey, the local address on the key server, this is the local address on the key server. That's going to be, involved in this whole Get VPN setup. And then we set up the redundancy. Local priority is 100, the higher the better. And then my peer is the other key server, which is 192.168.1.253. Now, the only difference between this entire setup on key server 2 is the priority is 99, and obviously the peer address is different. So if we do show crypto GDOI key server coop, that's going to show us, hey, we're alive, we're the primary, and there's the secondary down at the bottom. Now, if I wanted to get a little bit more details, I just take out the coop and go to detail. That gives you a little bit better. All right, so Get VPN is the name of the group. Access list 100 is what our interesting traffic is. There's a local address, we're alive, and we're the primary. So if I showed you the access list, as you can see, the access list is going to say anything in the 192.168.0.0 or /16 going to 192.168/16. That's going to be the interesting traffic that is going to get encrypted. Now, you would do that as long as you have your sites set up where everyone falls into this major, like the /16. If it wasn't, you'd have to add another entry to get that to work. Because if you have like a 172 address subnet, well, then now you have to add that in there. This is where design comes into play because you got to make sure you design your network correct so you can easily configure this and not have all this complication because you have different subnets all over the place. So basic VSLM, basic subnetting, that needs to be done correctly before you even try to do something like this because it's more of a headache if you have different subnets all over the place. So again, on key server 2, we can run that same command so you can see it. So show crypto GDOI KS detail. As you can see, we're configured here. We are the secondary. We're alive and our KS role is secondary. So now that all of that is set up, the only thing we're really going to worry about here is CE to CE. So what I'm going to do is I'm going to capture traffic on G02. Make sure Wireshark comes up here. And then I'm going to do a simple ping so you can see that is in clear text. Now we're going to open up Linux terminal real quick, little lightweight Linux, and we're just going to ping 192.168.2.1, which is on the other side. This is 1.1 that I'm pinging from. So as you can see, all clear text. I can see exactly what that is. Okay. That's what happens when you use MPLS. All clear text. If I click on here, I can see exactly what everything is. Yep, I can see that this was this ICMP. Now, if you have other stuff, I would be able to see it. This is why I say MPLS is not, MPLS is not secure from a encryption standpoint, from a clear text standpoint, from a traffic separation standpoint. It is. Now, I was doing it from the CE. Let's do it from the PE so you can see for yourself. Because somebody might say, "Well, you only did that from the CE. Of course, it's going to be is not going to be protected." So we're going to do G2 from this side, and we'll run that same ping test that we literally just did, so you can see it going in. Clear text, clear as day. So again, if someone was able to get somewhere in your network into a Wireshark, they can see everything going through. If there's passwords going through, stuff like that, and it's set in clear text, you could see it if you got Wireshark, right? Now, what we're going to do from the CE side, let's pull this here, open this up just a little bit, is I've already pre-configured some of this. So we look at the show crypto, going to be the same phase ones. All right, same phase one setup here. Now, again, for security purposes, in the real world, you would adjust this key to make sure it's locked down to specific subnets or specific peers. Now, the only thing that's different from the key server and the members is the group configuration. So you do your crypto GDI group get VPN, you're going to do your identifier number, but all you have to do is say, okay, just tell me where the servers are. The server's going to handle everything else. And then you do your crypto map right here. And what this basically says is, hey, this connection or this VPN is going to be set up by GetVPN. Now, in normal peer-to-peer, this will be set up by ISACamp, right? So this would be ISACamp as the keyword and not GDOI. Now, once I apply this to the G02 interface, it's going to reach out to the servers. It's going to get exactly what I said, the traffic encryption key. It's going to get the interesting traffic, and it's going to get the public key from each key server so that it can decrypt the rekey messages. And then when I do it on the other side, that traffic will be encrypted, and then we'll do the same ping test, and then you'll see ESP packets and no more clear text. So let's go in here, go to G02, and we just do a crypto map and get VPN. What did I call this? Oh, VPN, sorry. Let's make sure we take that off because get VPN, I called it VPN. All right, let's call it VPN. So now that comes up, start to register. And successfully registered. And we should be good on that part. Now, it may take some time to register with 3, which is the second one, but we're good to go with the main one. So now, I'm not going to do the ping test yet, but we're going to go to the key server. And this is primary. So yeah, it's going to go to the primary first and not the secondary until the primary is down. So we're going to go to key server here. And we are going to go to key server members. I think there's a detail in here. There we go. So let's see. We have a member right here. So this is that interface here. We got a member key server here. We're good to go there. And we're registered. Okay. Now again, because we registered with the first key server as the primary, we're more than likely not going to see anything here. Oh yeah. All right. Yeah. We shared it there, so we're good to go there too. So we're already, oh yeah, I forgot, because the redundancy we already shared because it shares when it connects it. So I haven't done this in a while, so amazing how I forgot something so small. But again, we're there. So now we're going to do the same register on the other side. Right? And then when we connect to the primary, that will be the secondary. So the secondary is ready to go. So let's go up in here. Funny how you just forget everything. I haven't done this in a while, but so we'll register here and we should be registered. So we're good there. So we are now registered on both sides. So let's go back to the key server. Come on. And we'll look at the register. We have two members there, 1 and 2. Registered, good to go. Now remember, on the CE, we didn't have phase 2 set up. That phase 2 comes from the key servers. And as you can see, a rekey message just went. See, another rekey message just got sent. All right, and then on phase key server 2, we should have the same two members. So boom, we got the same two members. And now on the CE, if we do show crypto sessions, we should see the complete setup already ready to go. So show crypto sessions. So there's our phase 2 right there. All right. This is our phase 2. So if you want to see show crypto Isocamp, it is SA. So we're active there. So that means phase 1 is up. I'm going to do show crypto IPsec SA for phase 2. And there go our phase 2. So there's our phase 2. Here's the interesting traffic, all of that. So as you see what I'm saying? So that phase 2, phase 1 and phase 2, we already had phase 1, and then phase 2 got automatically downloaded from the key servers. And here's the tech right here. The traffic encryption key was updated, and then we got another rekey message from the primary. So you'll see this because I have logging on. Now, here's the test. Here's the rubber meets the road. So let's go ahead and capture again from the CE side first. And then let's run that same ping test. Hopefully I captured the right interface there. And as you can see, they are now ESP packets. So we just go to Wireshark ESP. Now it's a bunch of garbage, bunch of gobbledygook. You can't really tell what's in the packet. This is the benefit of using GetVPN. Now a lot of people that have MPLS don't have this set up. And again, I showed you last time, it's all clear text. Once you establish GetVPN, everything is protected. Now you may have some regulatory uh, things that you need to follow that says, hey, all your traffic has to be encrypted. Well, if you're not doing GetVPN and you have MPLS, you're non-compliant already. If you establish or you configure get VPN, now this is most of the time your service provider is going to do this because you probably don't own your own MPLS backend. This is probably your provider providing that. So you're going to have to talk to your provider to see if they can get you set up with Get VPN so that you can make sure you're secure even over MPLS. And then they'll set up all this good stuff here. But as you can see, all packets are now encrypted. We can't see anything. We can see the original header information, which is just, hey, let me slide this over real quick. We see the header information that says, hey, it's coming from, 192.168.1.1 going to 192.168.2.1, but we don't actually know what that traffic is because it's encrypted. So that's the benefit. And just for the people that want to know on the other side, hey, you know, is that traffic truly encrypted? Let's see if I can capture it from the opposite end PE side. We'll run that same test. As you can see, still pops out on the other end as an ESP packet, and it will not get decrypted until it gets to the other CE. And you could just keep adding CEs and CEs and CEs and CEs, and they're all going to be able to communicate to each other protected, right? They're going to be encrypted. It's going to be protected from prying eyes. So this is Don for Padlock Technologies, showing you the benefits of GetVPN. Hopefully this video is informative. Don't forget to share, comment, like, and subscribe. Thank you, and have a nice day.